Good morning, everyone. Welcome back to Guided by the Word Boyd Delp. As I said in a previous video, I'm going to be doing welding videos because that's been my life, welding. I've been welding for over 50 years. So what I want to do is share with you knowledge that I have. I'm not a prima donna. I don't know everything about welding, but I have done it for a long time. Different welders have different backgrounds, different experiences, different techniques. Welding is a vast trade, and there's a lot of technology in welding nowadays. But what I'm going to do is go back to Welding Basics, which is from the ground floor up, and try to teach people about welding. And hopefully these videos can be helpful. If you're spending time under the hood and watching a puddle, then that's what this is about. I can teach you, as in my first video, about watching the puddle and different things and techniques to help you learn. So if you're familiar with burning a rod, or if you're just a very beginner, these welding basics videos will be helpful to teach you how to weld. So I'm going to have to turn and focus on this. What these are AWS data sheets on an E6010 welding rod. One of the most versatile, highly used welding rods out there. I love a 6010 welding rod because of its versatility. So first of all, and I have over 50 years of welding experience, has been mostly in small or shielded metal arc welding or stick welding, and GTAL, gas tungsten arc welding, aka TIG, tungsten inert gas welding. These are synonymous with each other, I'm a certified welding inspector through the AWS, American Welding Society, and have welded on all types of industrial plants to include nuclear power plants. I worked as an inspector on Vogel units, facilities 3 and 4, and helped to build units 1 and 2 as a welder. My intent for this page, located at Guided by the Word Boyd Delp, my YouTube channel, is to share my basic welding with others, as it is very rewarding to give back. I intend to produce video content to show several techniques on flat plates as well as open root, and on bevel plates as well. So I hope you enjoy the videos. They can get lengthy. I can't teach you how to weld in a 1 minute or a 3 minute video. I may do some shorts from time to time, but in order to learn how to weld, it's going to get lengthy. So I'll try to keep them to a minimum, maybe 30 minutes or something, depending on the criteria focused on for that day. So today, what I'd like to focus on is the E6010 welding rod. As I said, it's a very versatile welding rod. I love a 6010 because of its versatility. 6010 is a high cellulose coated electrode designed to provide a smooth, stable arc force, enough to achieve deep penetration into base metal. So what that means is it's basically a paper-based flux on the outside of the mild steel core wire. It's designed within itself to get deep penetration into the base metal, and primarily base metal of mild steel as well, mild carbon steel. However, on some welding machines, you have arc force adjustments, which basically arc force, it has +1, 2, 3, or a -1, 2, 3. Arc force, think of it this way, is like digging a hole with a shovel. The greater the arc force, the more dig this welding machine is going to help this rod, which is designed for dig from the get-go to dig into the base metal. So I like to weld when I'm doing an open butt root pass, for example, and we'll get into that down here. I like to use lower, colder amperages with an arc force or a dig of a +1 or +2, generally a +2. What that does is allow you to decrease the amperage, increase the dig to dig into the base metal, and maintain an arc at colder amperages. It allows you to slow down, focus more on the puddle, and put the metal where you want it to go. Exactly. It's just amazing. I will do some videos of me doing it in the future so you can actually see it being used on a weld or in a weld. So 6010, the one I've come to know is more of a modern day 6010, is produced by Lincoln Electric. It's a 6010 5P plus. Has 3 green dots on it. It's a gray rod. I really do like this welding rod. They make other types. They make 6011s, 6013s. I just like a 6010. I've never had or used one that did any better. I don't see any need personally for any other rod. This is just my favorite rod. So the tensile strength of this rod is 60,000 pounds per square inch, PSI. What that means is basically that the weld metal in this rod has been tested to fracture or break at 60,000 pounds. The way they test that is what they call, what they do is cut out a dog bone out of this material, and they have, you can see they clamp here in a hydraulic machine, and they pull until this metal breaks. Where it breaks at is how they test the tensile strength. So as they're pulling this dog bone apart, it will begin to elongate or deform because of the stress created on it. That's measured as well in the test. But when this dog bone or this base metal fractures, that's the strength of this weld metal. So this rod has a tensile strength of 60,000 PSI. Okay, so the E6010 electrode is designed for deep penetrating arc for 100% penetration on root passes. Generally, that would apply to pipe welds in general. But this rod is good for any application. Whether you're welding on pipes and fittings, tubing, root passes for structural applications, vats and containers, dumpsters, right? We got a lot of dumpster welders out there. But what I'd like to do is help to teach people to be quality welders that can actually take nuclear power valves tests and weld and make big bucks in welding. So deep penetration, 100% penetration for root passes, and does not need to be stored in a rod oven. What that means is that, as for example, a 7810 electrode, a low hydrogen rod, has to be stored for best function and best quality of the weld in a rod oven to keep moisture out of the rod. These are designed paper-based. They actually run better with a little bit of moisture per se in the environment. You can lay those over there on the table or put the box of welding rods up on the shelf and just leave them open in the atmosphere. And whenever you need them, just go grab them down and use them, and they work perfectly fine. Okay, so in general, for quality welds, base metal should always be cleaned. Don't ever make a weld. If you're trying to make a quality weld, the very first thing you want to do is clean the base metal. This rod right here will burn through dirt, rust, it doesn't matter, paint. That's another thing I like about it, but it's okay to understand and know that. But for quality welds, always clean your base metal. By mechanical means, cleaning, you can use grinders or whatever, but you get the idea of cleaning base metal. I talked about cellulose. The coil wire of an E6010 electrode is made of mild steel. Mild steel is a low carbon steel which is more ductile or bendable, malleable or shapeable, and weldable. So the mode of welding with the E6010 electrode is a DC current or direct current, in which the electrode holder is hooked to the positive side and the ground is to the negative side. Now, just to break down the E6010 electrode, E equals electrode, 60 equals 60,000 pounds tensile strength. 1, E6010, 1 can be used in all positions, overhead, flat, doesn't matter. And 0, as in 10, E6010, is the flux makeup. So the most common, there are a lot of different techniques welders develop their own techniques, but I'm just going to share a couple of my own techniques with you this morning, so hopefully to simplify and help you to understand what motions or techniques you use with an E6010 welding rod. You can use what is most commonly used is what's known as a whip and pause. That will work on flat metal if you're just putting bead on flat plate. It will work on open butt if you're trying to put an open butt joints as in pipe to give you a good root pass. So whip and pause is probably the most popular used technique in the welding industry, especially pipe. One that I developed for myself, and the guy in the class, in the welding class, had me welding 10-inch coupons. Wall thickness was about 3/8 an inch, 10-inch pipe coupons. And I was having to grind face landings on these coupons, 10-inch coupon, grind the landing on the other one. And I was going through them, not fast, but I did go through a few of them until I just got tired of doing all the grinding. So what I did from that point on was I just started cleaning everything up real good with a flapper wheel. I had a knife edge on it. I put my 1/8 wire in there to establish my gap. I used the 6010 rod, of course, and I turned the arc force or the dig up to +2. Turned my amperage down to, I don't remember, it might have been, this is gonna sound cold to you, 60 or 65, which that's what the arc force does. It helps you to maintain the arc, be able to slow down and watch the puddle as you're welding. So that's what I did. And the root passes, even on a knife edge, were going in there slick. So the other one, so that's the whip and pause. So, but there now, what I was doing there, I'm getting ahead of myself a little bit, was using a C motion. So a C motion is basically what it says. I was carving the walls, coming down, going across the root pass, coming up the other side, carving the wall, up and down, coming back down. And as I came down, I was coming back across the root pass. And that's what I did continuously all the way up this joint and putting a perfect root pass in there. So that's what I'm going to share with you on a video for basic welding whenever I get to that point. So, okay, so just to reiterate, the two motions that I prefer is whip and pause. A whip and pause motion of the electrode is also acceptable and more common. I used it for years, but for beginners, the C motion allows slower travel speed and better focus on the puddle. The C motion, on the other hand, you're able to run colder at approximately 60 amps, plus or minus, probably a little hotter than that, 60, 65 amps. And if your machine has arc force control, use a +2 arc force. This enables running a slower travel speed. Amperage dictates travel speed. Always remember that. The hotter your amperage, the faster you're going to have to move, or you're going to blow a hole in whatever it is you're welding on. So this enables running a slower travel speed while improved maintaining of the arc at lower amperage or less sticking of the electrode. So I hope this has been helpful. As I said, I will in the near future have plates and do actual welding videos on the root pass, open butt, so you can see exactly what I'm talking about when I say carving the walls. Look, if you carve that wall on an open butt, if you carve that wall, that's your penetration right there. The whole point of an open butt root pass is to get you're joining two pieces of pipe to join these two together. If you're carving the walls, coming across, establishing the root pass, carving the other wall, as you carve, that's your tie-in, that's your penetration, that's your joining the two pieces together. And you're running so cold that you can actually see the layer as you stack it, layer upon layer, just like stacking bricks. It's so cool when you get to see it, you're gonna like it. So I hope you've enjoyed the video today. Remember that Jesus Christ is Lord, and John 3:16. For God so loved the world that whosoever believeth upon him should not perish, shall not perish, but have everlasting life. Thank you and have a blessed day. Okay, everyone, so just before I go, sorry, backing up just for a second. I'd like to ask everyone, if you will, if you're really interested in learning how to weld in these videos, like and subscribe to my channel. And also, I'm going to try, I think I can, make a copy of this and put it in the comments section. So thank you again. Have a blessed day.